Okay, let's talk about something really fundamental when you're writing code. Sometimes, well, things just go wrong, don't they?
Oh, absolutely. You get unexpected input, or maybe something during execution doesn't quite work as planned.
Right, and your program could just stop, crash. So how do we handle that? Specifically in synchronous JavaScript code, make it more resilient.
Well, thankfully, JavaScript gives us a standard way for exactly this kind of synchronous situation. It's the try.catch.finally structure.
Ah, try dot catch dot finally. Yeah,
Uh,
heard of it. It's like the classic safety net, right? For
it,
code that runs step by step.
exactly, it's built right in.
So break that down for us. What's the try part about?
Okay, so the try block. Think of it as your test zone. This is where you put the code that you suspect might cause an issue.
The code you're trying out, basically.
Precisely, the potentially risky stuff goes in try.
And if something does go wrong in there, if an error happens,
Then execution immediately stops inside that try block. It doesn't continue with the rest of the code in try. Instead, it jumps straight to the catch block.
okay, the catch block. So this is where you like deal with the problem.
Exactly. The catch block only runs if an error occurred in try. And importantly, it gets past an object, an error object.
An error object, what's in that?
It usually contains details about what went wrong, like the type of error, maybe a syntax error if you tried parsing bad JSON.
Oh, right, like JSON.parse on something that isn't JSON.
Exactly. Or maybe a type error if you use the wrong data type somewhere. The catch block gets this information, and you can decide what to do.
Like what? Log it. Show a message.
Yeah, all of those. You could log the error so you can debug it later, maybe show a friendly message to the user instead of just crashing, or even try some kind of corrective action if it makes sense. It's your handler.
Okay, so try is for the risky code. Catch is the error handler. What about finally? Is that always involved?
It is. The finally block is the part that runs after try finishes or after catch finishes if an error was caught.
Wait, so it runs no matter what? Error or no error?
Correct. It always runs, guaranteed, which makes it really useful for cleanup.
Cleanup. What sort of cleanup?
Think about things you need to do regardless of success or failure. Maybe you open a file that needs closing or started a network request indicator that needs hiding.
Ah, right, like stopping a loading spinner or releasing some resource.
Exactly. Putting that cleanup code in finally ensures it executes. It's generally safer than putting it after the whole try.catch structure because, the catch itself could potentially have issues or rethrow an error. Finally provides that guarantee.
That makes a lot of sense for reliable code. Okay, so try.catch.finally seems pretty powerful for synchronous stuff. But there's a catch, right? A
Yeah.
limitation.
There is, and this is super important. It trips a lot of people up. Try.catch only works for errors that are thrown synchronously within that try block.
Synchronously, meaning like right then and there, as the code is executing line by line.
Exactly. Immediate execution. It does not work for errors that happen asynchronously.
Asynchronously, like,
Yes. Think about code inside a set timeout callback, or an event listener callback, or inside a promise dot and then block if you didn't await the promise inside the try.
so if I wrap a set timeout call in a try.catch, but the error happens inside the function that set timeout runs later,
The catch block won't cache it.
really, why not?
Because the try.catch block finishes executing almost immediately, it successfully schedules the set timeout, and then it's done. The error inside the callback happens, say, 100 milliseconds later, long after that try.catch has finished its job.
Wow, okay, that's a huge distinction. So try.catch is for the immediate problems, the synchronous one.
Precisely. It's essential for making your synchronous operations more robust, letting them fail gracefully instead of bringing everything down. Understanding the structure and its limits is key.
Definitely a big step towards writing more solid, predictable JavaScript,
Absolutely. It helps you manage those immediate sequential potential failure points.
which naturally leads to a question, doesn't it? If try.catch is primarily for synchronous errors, well, what do you do about errors in asynchronous code? Those set timeout errors or errors in promises or event handlers, how do you handle those effectively? In JavaScript, what are the strategies there?